and the another one is B. This can be 0.4 and 0.4.
Why are you shouting?
And let's simulate. Okay, so here we can see that this guy is passing. Okay, this is select line. So he passes one input. He's not passing the second one. So let me check what went wrong. Okay, the select input is connected to this one. The output is, so when input is high, hold on. Okay, the B input. Oh, the outputs are not shorted. I'm so sorry. So I have to short the V out. Now it should be okay. Yep. So he's passing both the inputs now. So are you able to follow the same stuff? In my multiplexer, which I've sent, a multiplexer which I've sent you, only the output node was not connected and the inputs were not applied properly. So that change you have to bring. Okay. I will await for confirmation from majority of the class that you guys have followed it. Okay, I'll wait for the majority of the audience that you guys have followed it. And okay, anyone? Any questions, doubts? I love answering doubts. Okay, Muskan is getting worried that how I became host. Muskan, these days it's very easy to become host. Just like, uh, I heard a joke about the Corona incidents that in some government office, the magistrate or the higher most guy, he got infected and his deputy got promoted to head of the office, and he also got infected. So the next level guy manager also became the head of the office, and so on, so on, so on. The peon was making a joke to his friend that agar aise hi, if this continues, then in the next 15 days I have to be the head of the office. So it's the same stuff. Okay. I don't know why, but today I feel like very slow day. We have just made couple of circuits only. Maybe I'm too slow to explain and progress. Maybe it's just a weekend blue. Uh, Yesterday was Sunday now, so I enjoyed a lot. Although these days every day is Sunday, but still I consider my Sunday as a Sunday one because I don't work much on Sundays. Hmm. Uh, okay. Okay. Anyone, you guys have doubts, questions on this multiplexer? Okay. I think we have only this much time remaining that I can just cover a few things and proceed ahead. Okay. Today I will just give you one assignment, one simple one, which is okay, which can be a study experiments, nothing to draw. Okay. Parameters of select. Parameters, it would be a square wave, which is slow one because you are allowing, to select A input and the B input, and both of them you are giving equal amount of time to share. So you can give anything like 5 low and 5 high. Okay, that's it. And just say assign, select one. Sorry, and for the A inputs, you can make one low and one high or something similar. And the B one, you can make it zero point 0.4 high or 0.4 low, anything like this. Okay, something different so that you can identify that, okay, this is A and this is B in this simulation. That's it. Okay, so here you see that this is the simulation output, and when the select is 0, he's passing A. When the select is 1, sorry, when the select is 1, he's passing B. Okay, that's it. So it just works as a 2:1 multiplexer, and this is how your all data buses works. Okay, this is how your data bus works. Okay, data bus, you understand? I assume that the answer should be yes.
Yes, sir.
Okay, I just to open this. So you have a microprocessor and a RAM here, right? And maybe another RAM here, something like that. So you have the same data bus connected to all of them. Okay. The only thing is that this guy has a different chip select. So this guy chip select is different, and chip select to this guy is different. Okay, isn't it? So what is over here? What is over here? This thing, this junction, like, okay. So as the data bus is shared, okay. So you have a microprocessor. Okay, so this, like, assume that this is the data bus. So this is from D0 to D7, all of the data bus. So what is at the RAM side? So I just open one of the RAM side or any of the peripheral. All of them are same. Okay. So this guy has, okay, a driver over here. Okay. So this is chip select. Okay. So when chip select is high for the RAM, then only he throws the data on all of the buses. So this is like this guy is 8 wired. It's easier to understand. This is data bus. Okay. This is easier to understand. Okay. So this is 8-bit data bus. So all of the data bus, all of them are enabled when the chip select is high and it throws the data. When the chip select is low, the traction buffer is open, is cancelled. Okay. So that the microprocessor can place its data on any of the other RAM device. Okay. So he can place the data on all of the others. And the input is common. The input of this goes to the RAM anyone, because he will not write when the chip select is not of his. Okay. So this is how the writing happens. Okay. This is how the writing happens in the memory. So this mux, what you have made, transfer buffer you have made, is a very important component in many of the circuits, in memories, in like your ADCs, everywhere. So this same component is being used. Okay. Okay. So today's your assignment is a study assignment. Okay. And I just share stuff first. Okay. Okay, so today is your study assignment. You have to just open this assignment. You have to just say file open, go to C program files where Micron has been installed at your local computers. And in Micron example folder, you will find a PLL, the same stuff we have opened earlier. And you will find a pll.msk. Okay, just use pll.msk, nothing more. So he will give you a warning that this was designed 0.12 micrometer. So I select CMOS 012 by going to File Foundry, select 012, CMOS 012. Okay, so this is an design of a phase lock loop, a very basic one, a very, very basic one. Okay, but still it's good one. I've seen many papers written on the very same design. I mean, many people have used the very same design to publish their research work. They have made some small modifications and they have said that they have made a big change in the PLL design, and that can be do wonders in the world, and papers have been published. Okay, so this is a PL. Okay, so what do you see here? You see here and VCO on the right hand side. Okay, you see a VCO on the right hand side. Okay, and on the left hand side is a phase detector, which is an XOR gate. Okay, there is an XOR gate. Okay, there is an XOR gate on the left. Then there is an RC filter in between, because whatever the output coming from the phase detector, which is an XOR gate, has to be filtered. So there is an RC filter. You can see a resistance and a capacitor over there on the same node. So they will filter out any high frequency signal and apply to the VCO. And the VCO we have seen on the previous days, that is just a free running ring oscillator, but it's not free running. You can control the output oscillations by the help of the voltage. As the voltage will increase, the frequency will increase, and vice versa. So it settles down around 1.9 gigahertz around. Okay. So we can just start simulation by changing the clock scale to something higher value, time scale. And you can see that starts over there and the VC settle down, and the output high voltage also settles down after a while. And maybe I can change the step size to 1. So for faster simulation. Okay. And you can go to frequency versus time and see the graph over here. So you can see that it starts oscillations, and after a while it settles down to 1.9 gigahertz. That's good, great, fantastic. Okay, so you can see this, see the output waveform, see how it's working, try to understand any of the outputs coming up. I'm not sure, will it be easy for you guys, or will it be too easy or too difficult? I'm not sure. So, but still I want to give a try that let's see how you guys make up of this experiment. My only one question to you, that tomorrow try to come with an answer for the question is, on the left hand side you see a phase detector. Okay, there are many questions on this phase detector which I'm skipping, like why XOR gate is used as a phase detector. Does it really work as a phase detector or not? Can it be a comparator over there, or something analog design can be there or not? I'm skipping all that question. As of now, establish this fact that an XOR gate has been used to work as a comparator or a phase detector. Okay. So my question is, do you see this design? You guys have seen an XOR gate design this morning. I mean, this start of this class, an XOR gate. So at the last stage, you have an inverter. So why this red body is so big over here? We have still now so far not seen something like this earlier. So we know this, that the this one, top to bottom, is called as the width of the transistor. So width looks a normal width. It's not too wide, not too small, but okay types width, which we have seen now. But the length we have not seen so far yet. Length is huge. It's a mammoth size as of now, what we have done till now. It looks like 10 times the size of the length of what we have seen till now. So why is that? Why the length of this inverter is so large? Till now, we have only talked that length should be as small as possible. So why length of last stage inverter of XOR gate is so large? Okay, only this question I would like to discuss tomorrow. Okay, this is the question I would like to discuss tomorrow when we meet. And apart from this, yes, you can explore the PLLC around, how does it work, try to understand the components which are attached to it, simulate it, see, make any changes if you wish, okay? And try to collect some questions as you wish, okay? And tomorrow, this is the only one assignment I would like to give today, for today, okay? Because that will make a quite changes the way you look at the perspective of the layout, okay? Any questions till now? Any questions you guys have? Any questions you guys have? No? Am I audible then? I'm not sure, like from few minutes, I have not got any response.
Yes,
So I'm
sir,
just
you are
wondering.
audible.
Great, thank you. So if you have any doubts, questions, we can continue, or I would like to end for the day and we catch up again tomorrow. And we start with the question like that, why the XOR gate length is so large? Because till now we have only discussed that length should be as small as possible, because when the length is small, current is higher, right? So here the things are vice versa. So why is that? Okay, why is that? So try to see this. So open this example. Shall I share the example file, because then you need not to find it in your folders. I just share the link. I'm just sharing the file here so that it'll be much more easier. Oh yeah, sure. I share all the files of today. Share the today's files so you can use them. Okay, guys. So we conclude for the day, and we catch up again tomorrow at the same times. If you have any doubts, questions, you can write on the Google Drive, and I try to answer them by tomorrow. Okay. See you then. Bye-bye.
Thank you, sir.
Bye-bye, everyone.